Good morning and hi everyone. Now we move to the part 3 of the hydrogeology. This is where you need to know about the terminology of aquifer, aquicludes and aqueducts. Okay, all of this is inside your earth crust, and this is specially for groundwater, or what you know as hydrogeology. So aquifer, aquicludes and aqueducts is the space inside the earth crust that contain water. Why we have different terminology, it is reflects to the ability of you to extract water from these three places. Okay, aquifer is a place to reserve water inside the ground. Aquiclude also is the place where you want to reserve water, and the same goes to aqueducts. The difference is how you can extract water from all of these three. Okay, for aquifer, how you define aquifer? Aquifer is a body of saturated rock or sediment through which water can move easily. Good aquifer includes sandstone, conglomerates, body of sands, and gravel. You can imagine a sandstone conglomerate. Sand and gravel has the ability to store the water, and because of this material have a lot of spaces, and the texture of this material is actually like grain size, so it allow water to move. At the same time, it has the ability to store water. To compare with aquicludes, it is a geological formation of layer comprised either of clay with tiny connected pores on non-porous rock that restrict water from flow one aquifer to another. The same thing, it is a place to store water, but it don't. This kind of storage or aquiclude do not have the definitive network, so you have the difficulty to extract water from aquicludes, but still you can extract some of the water. But to compare with the last term, which is aqueducts, it is a geological formation that absorb and hold water but does not transmit it at a sufficient rate to supply, for example spring, well, and etc. So if you have groundwater but it is very difficult for you to extract water from it, that is what we call as aqueducts. So you can differentiate all of these three in terms of the definition, and you can also differentiate in terms of the rate to withdraw water from these three places. Okay, aquifer has high permeability and high porosity, where K is more than 10 to the power of negative 6 meter per second. If you have the the symbol K, this K is reflect to permeability. So for the example of sandstone, dolomite or limestone, and of course fractured rock. So remember, we already explained about porosity, the space inside your reservoir, is the space inside your groundwater area. So that is the function, or that is the factor you can withdraw water or you cannot withdraw water from groundwater body. For aqueduct is where some water passes through, which is due to fractures, heterogeneity or intermediate permeability. For example, high clay soil, sparsely fractured rocks, and anisotropic rocks. This one you can still extract water but with some limitation. For aquicludes is where no water passes through with, because the permeability is very low. So the permeability is K is less than 10 to the power of 9 meter per second. For example, clay soils, unfractured low porosity rocks, highly anisotropic rocks. So in this discussion of hydrogeology, you also need to discuss about transmissivity and of course storativity. Okay, transmissivity is the rate at which water is transmitted through a unit width of an aquifer under a unit hydraulic gradient, and for a confined aquifer with a thickness B is given by T is equal to K multiplied by B. For storativity or storage is the volume of water that an aquifer releases from storage or unit. Surface area decline in component of hydraulic head normal to the surface given by S equal to SB. So this is in terms of storage, and transmissivity is about the rate. Okay, you can actually look at this picture to define aqueducts and aqueducts. All of this is like a layer inside the earth crust. But of course, what is the difference between aqueduct and aqueduct is the permeability. So you have water table in the area of sand. Of course, you can withdraw water from this area. But if you have semi-porous silts, you have the difficulties to withdraw. But if you have aqueducts, you know that inside aqueducts there is water, but it's very hard for you to extract water from aqueducts. Okay, this is to define to explain about confined and unconfined aquifer. Okay, sometimes we also define these aquifers as artesian. So generally, aquifer are geological formation that contain sufficient saturated permeability material to yield significant quantity of water to well and spring. Okay, sebelum you install telaga ataupun perigi, semua kawasan tu adalah kawasan simpanan air. Once you dig your borehole and then you find some water inside that borehole, and when you use pump and you need to withdraw all of this water from that area, but the water keep coming in, you know that you have hit the artesian, of you have hit the aquifer. Okay, if you have unconfined aquifer, the water table normally takes the form of a subdued replica of the topographic surface, rising beneath hill and falling towards valley bottoms, where natural stream water level approximate to the groundwater level. An aquifer is said to be artesian or confined, where it is overlain by an impervious horizon, so that when pierced by a well, the groundwater is under sufficient pressure to raise it above the base of the confining bed to height dependent on the pressure head. And of course, we do have piezometric surface is applicable to both pressure surface and water table. Okay, let's see to the picture to really understand what is unconfined aquifer and confined aquifer. Confined aquifer is more at the surface of the earth crust, where you can actually take out the water table easily, and there is no definite layer to confine this aquifer. So it is more like surface flow, but inside the soil or inside the rock. For confined aquifer, you have two definitive layer, so that we can define this aquifer as confined aquifer. So let's see in this picture, you have the upper layer that confine the aquifer, and then you have bedrock underneath. This is two definitive layer, and we call this area as confined aquifer. Okay, so this is for part 3. We will move on to part 4.